I'd like to give several examples now of how to set up hypotheses based off of a particular setup to a situation. I'll give you a second to read this. So what this instructor is interested in right now is seeing whether there's a difference between online classes and face-to-face classes in terms of how they score on their exams. And she's got this kind of baseline value where her online classes have an average of 82 points on their final exam. So I'm given a mean, right, an average of 82 points. That should be kind of leaning us into, oh, that's probably what I want for my hypotheses. But it says she wants to determine if face-to-face classes have different average scores. So definitely now as I see this, all right, we're talking about differences in a mean. So I should have a mean in my hypotheses. So just kind of flipping over to my board here as I write out my null and alternative hypotheses. I know I'm going to be looking at a mean here, and I know that I'm going to have 82, right? That's my baseline average for these because that's what she's looking to see. So 82 is my mean for online classes, and I'm seeing if my mean for face-to-face is different from that. It just says we want to determine if there's a difference. Well, wanting to show one thing or another doesn't really inform us here, or putting a burden of proof doesn't really put us anything. But there is something that will tell us exactly where things have to go. I don't really have a choice because of this. Remember, the null hypothesis has to have an equal sign, so, okay. So where's the only place I could put there's a difference? Well, right here. All right. So this would mean there's a difference. It might be less, it might be more, I don't know. But if there's a difference, it would appear in the alternative hypotheses. I'm not allowed to put there's a difference in the null. This is always an equal symbol. So that's how I get through that first one. Now why don't you take a look at this? So we've got this historical percentage of 1.3% of teenagers have used heroin one or more times. And then we've got this recent survey, and we want to test if there's sufficient evidence to support the claim. Now, that's already telling me right there that the claim that's following right after that is the alternative hypothesis. Remember, we can only support the alternative. So is there sufficient evidence to support the claim that heroin use has increased? Okay. So heroin use is a categorical variable here, like have you used it or have you not? So I definitely want to be looking at proportions here, and indeed, as we look at this, that's indeed what we should be thinking about. And we want to see if it's increased. In other words, that it's more than that historic 1.3% proportion that we had in previous years. So, I'm looking at proportions. I'm looking at 1.3%, which would be 0.013 written as a decimal. And I want to see if it has increased, or if I want to see if I can support that claim that it's increased. Well, if it's increased, then the current proportion is more than the old one. And again, since I'm asked if I can support that claim, that better be my alternative. And again, once I have this set up, this always has an equal sign, so the null hypothesis kind of just writes itself. All right, let's try one more. So now we've got a tire company that wants to show that their tires will last through the warranty period. That's kind of the whole purpose of this, is establishing that it will last through the warranty period. which means that it lasts at least 60,000 miles. All right, so I haven't specifically said whether we should use a proportion or a standard deviation or a mean, but a proportion makes no sense here, really, because what we would have here for data is how many miles the tires had on it. I suppose it's possible we could have as a simplified thing whether or not these tires last through the warranty period, but that really doesn't help us with comparing it to this guarantee of 60,000, right? Because we want to set that 60,000 as the warranty period. So we want to number data here. That's the only thing that would make sense. So we want to show, so this is one of those times where we could actually use like, what's the purpose of this to decide which should be my alternative and which should be my null here. So the purpose of this is to show that the tires will last at least 60,000 miles. And again, a proportion makes no sense. A standard deviation is how far apart the tires' lifetimes would be, which really doesn't tell us anything. What I want is like the idea of typically, all right, a typical value would be at least 60,000. Well, that's where I want to look at a mean. So what I want to do is, again, my hypothesis should have a mean. The baseline value I'm comparing that mean to is 60,000 miles. And the whole purpose of this is checking to ensure that this mean really is at least 60,000. Well, I can only show that that's true if it's in the alternative hypothesis. So if I want to show it's at least, I can just do more than, and this will always be an equal sign, and I'm done. That's all there is to it. And I've got a few more examples, but I'm going to save that for the next video.